And then when you're talking, you should see the green bar on the right bouncing around, and that means it's getting your audio.
This equation in trigonometry is very similar to this equation in algebra class. If I were back in algebra class right now and looking at this equation, I would try to get the x's on one side of the equation and the plain numbers, on the other side of the equation. I'm going to subtract 3x from both sides of this equation, and that will give me 5x minus 3x is equal to the square root of 3.
And they take a little while to upload, so if you're doing a quick sample, try not to make it too long.
Okay.
'Cause then you'll have to wait.
5x minus 3x gives me 2x's on the left side of the equation and the square root of 3 on the right side of the equation. To solve this equation for x, I'm going to divide both sides by 2, and x is equal to the square root of 3 over 2. If this were algebra class, I would be done. I would have solved this equation. However, over here in trigonometry class, we're going to see that I need to do a little bit more work. I, like the algebra class, am going to collect, this time, my signs on the same side of the equation by subtracting 3 sine x from both sides of my equation. I'm going to combine the signs, and I get 2 sine x is equal to the square root of 3. I'm going to divide both sides of my equation by 2, and I get sine x is equal to the square root of 3 over 2. Similar to the algebra, yet a little bit different, because we haven't solved for sine. We haven't solved for x. X is equal to the angle that produces this ratio for sine. So really, what we're looking at is the inverse sine of the square root of 3 over 2. And I'm saying, what angles for sine would make us get this ratio? The ratio is positive, and I know that sine is positive in quadrants 1 and 2. What angle produces this ratio for sine? It's a 60-degree angle. So my answers are going to be 60 degrees, and 60 degrees is going to be a reference angle in quadrant 2, which will give me a 120-degree angle. However, I want to say those using radian measure instead of degree measure. So I'm going to get pi over 3 and 2 pi over 3 as the two solutions to this particular problem that occur between 0 and 2 pi radians. That's it. So now how do I stop? Here?
Yep.